Today, I'm solving problem 22 from the AMC 10A of 2021. Inside a right circular cone with base radius 5 and height 12 are 3 congruent spheres with radius r. Each sphere is tangent to the other 2 spheres and is also tangent to the base and side of the cone. What is r? So, what we have here, we have this sphere. Now, this is a cone, but I drew it in 2D. Here, we know that the base radius is 5 and the height is 12. Now, the entire shape from above looks something like this. If it's tangent to the bottom circle and this cone line part, it's not really touching the edge. Now, so this is the view from the top. We have 3 congruent circles. All these points are the midpoints, and when you connect them, they form an equilateral triangle since all of them are congruent. Okay, this is also the midpoint of this big cone. Now, drawing a few line segments here, this is an equilateral triangle. If we zoom in on that equilateral triangle, let's call this an equilateral triangle. It might not look good, but it's an equilateral triangle. Well, first of all, we can split it in half. So this is congruent right triangles. And now, these lines here, well, these are from the center of the circle, so each segment has 2r, because r is the radius we want to find, and this is the radius, and there's another radius here. The length is, well, 2r, and this height, well, we want to find that height, and this length here is r, since it represents this equilateral triangle. Now, when you use the Pythagorean theorem to try and solve for this, let's just call it x. R squared plus x squared is 4r squared. X is equal to r times the square root of 3. So this is not x anymore. This is r times the square root of 3. All right. So, yeah, we have that. Well, now, there's also another property of an equilateral triangle. So it's like a drawing just like this with 3 circles and 1 midpoint of the big circle. Let's call it like this. Now, this property is basically saying that this height here, the first height, is 2 times the height of this second height. We know that the absolute height is r square root 3. So this first one is going to be 2 times r square root 3 over 3. And then this second one, this is going to be r square root 3 over 3. And we're referring to this bottom part. Okay, so we've gotten that out of the way. Now let's talk about this second figure. This is basically the 2D version, where this is one sphere. Well, we know that if we draw a sphere, so there's like a sphere here, and basically a circle. If we draw a line if the circle's tangent to a line, and we draw a line from the middle of the circle to the line, that has to be 90 degrees. So this is 90 degrees, and this is 90 degrees. And now we just draw this line to split it apart. Well, first of all, we want to actually find the lengths of the segment. Well, this is, let's see here. So, this total length is 5. I'm just going to move this, r square root 3 over 3. This total length is 5. We already know this length here, but it's kind of weird looking at it from the top, but we can still make it out. it's essentially, well, this distance, and that distance is 2 times r square root 3 over 3. Now we can also find this distance. This whole distance is 5. This is just 5 minus 2 times r square root 3 over 5 times 2 r square root 3 over 3. Well, now we drew a line that's, well, the circle is tangent to both of these lines. So we drew lines to make the right angles to each other. But now, once we split a line down the middle, we see that, well, these have a common angle. They both share the same radius, and they both share the same hypotenuse. So, therefore, these two sides have to be the same. So, these two triangles are congruent. Well, if these two sides are the same, then that means this side is 5. Oh, shoot. You know, this isn't part of the fraction, sorry. But this is 5 minus 2r square root 3 over 3. But this side is congruent, is the same as this side. So this is 5 minus 2r times square root 3 over 3. Well, we overlooked something here. This side is 5, and this side is 12. Therefore, this is a right triangle. We can use the Pythagorean theorem to find the length of this side, which is 13. Now, this is 5 minus this, then it would be 13. Well, the entire length of this hypotenuse is 13. We already know one length of these segments. We want to find the length of the other segment. So this is 13 minus 5 minus 2r times square root 3 over 3. This is equal to 8 plus 2r times the square root of 3 divided by 3. We're nearing to finishing this problem. We have this triangle here, and all the data we gather is on this. We can draw a line parallel to the base of the cone from the center of the circle to get a right angle here. And this height is 12. And this is r here, so this length of the segment here is r minus 12. Now, earlier we drew this radius. This is the radius, and we can basically cut it in half, except these triangles are not equal. But they do have the same hypotenuse, and we know the values of all these sides in terms of r. Therefore, we can use the Pythagorean theorem, except make both of these equal. So we leak out the formula. 12 minus r squared plus 2r square root 3 divided by 3 squared is equal to, this is r squared because there's only a radius here, plus 8 plus 2r times the square root of 3 divided by 3 squared. Now, once you simplify all of this and cancel out what can be canceled out and take out the factor of r and divide, you should get r is equal to 80 divided by 24 plus 32 times the square root of, 32 times the square root of 3 divided by 3. But even though this is r, this is technically not the correct answer because you notice it's not on the answer choices. So that means we have to go under a bit of simplification to get our final answer. Now we have this value of r here. We want to get our answer for r. They don't like the radicals on the bottom, but there's this divider on the bottom. So we multiply by 3. Then we divide by a common factor. We can divide by a common factor. And then we have to use a formula, and then to simplify it, we just get our answer here. That's our answer.